Do you believe you can select hundreds of Revit elements you want in just one click? You can, and I will show you how. Hello, I'm Clement, and I'm here to show you how fun and easy it is to create your own Revit plugin using Python, even if you have never written a line of code before. With the right tool, the model element you required could be selected in no time. This is my pre-built version add-in, which is used by the professional and those who without time to code. It's built with C# and have a modern interface, but you don't need to be a pro developer to get the same logic. Today, I'm going to teach you how to build the Python version. It had the exact same automation logic, just wrapped in a simple interface. Perfect for learning. Here, I've done the hard work for you. You don't need to type a single line. I've prepared the glue code on my GitHub. Just download, copy, and paste. You're ready to go. The code works perfectly, but if you want the modern UI, a dockable pane, and better error handling you saw at the start, or if you're busy and just want a done-for-you installer, you can get the Pro version instantly by supporting me on my website. Links in the description below. Now, for those who want to understand the magic, let's look behind the curtain. Manually, we would first open a wheel filter, then set parameter values. Finally, manually click element to select them. But here's the magic. Our Revit plugin follows this step, but does them automatically in just seconds. You can even add a second filter and choose AND or logic to combine them. Think of it like a Google search for your Revit model, but instant. How does XAML connect to Python? Think of it like a phone directory. The XAML is the phone book, lists all the names, and the XColon names is equal to each person's phone number, which is a unique identifier. And Python is the caller. It uses the number to reach the person. Here is the magic. The wpf.nocomponent will load your XAML file and create all controls. The XColon name will link each XAML control to a Python variable. And finally, the event handler will connect user action like click or selection to the Python function. The flow is user click buttons in UI, an event will be flyer, just like a button click. Python function runs automatically. Then the UI will update or the Revit will do something. Think of event handler like a doorbell. When someone presses a button, just like a user action, the door rings, which is the Python function runs automatically. Here's the glue code that brings our ideas to life. If you don't fully understand the code yet, don't worry, I will explain everything in detail in the next section. For now, just copy and paste the complete code into your script.py file and run it. How the script works? Here is the brief overview. The script follows a simple flow organized into 6 main parts. The first one is the line 1 to 20. It's setup phrase. It's import the tools just like a Revit API, window UI library, and then it's connect to the Revit document and create a whitelist of the allowed category just like wall, floor, door, window, etc. The second part is the helper function from line 23 to line 121. It is the utility function that extracts the parameter data, convert value to string, and search for matching element. Think of them as specialized to the window class used. The third part is the window creation from line 124 to 137. Create the window class and load the XAML UI design. It's connected to the Python and initialized empty storage container for the parameter data. For the fourth part, it is the initialization from the line 139 to 167. It is fill the category drop-down and set up event handler so the button and the drop-down know what to do when you click. For the fifth part, it is user interaction. It is from the lines 177 to 309. This is the event handler response to user action, just like the checkbox, the category parameter selection, or the clear button, and automatically load matching data. For the last part, it is the element selection, line 311 and 372. When the user clicks Select, the script finds all matching elements using the helper function and select them in Revit. Think of it like a smart searching engine for your Revit model. You tell it what to look for, and it will find everything instantly. Ensure you have already created your UI.xaml file, then copy the complete code into your script.py file and run it to see the magic happen. So, what just happened? How did the plugin select all those elements automatically? Let me break it down for you. This is the explanation part, where we will uncover the magic behind the scene. We will go step by step, starting with the basic setup, then diving into how everything connected and worked together. Let's dive in. For the first magic work, import Revit tooth. It is from the line 1 to 4. These are the first line of every plugin we write for Revit using Revit. Think of it as opening your toolbox. You give Python access to all the special tools needed to interact with your Revit project and create window UI. For the first sentences, from Revit import Revit, db, script, it gives us access to the Revit API and Revit utility. For the second line, it imported WPF. In long term, it is Windows Presentation Foundation Library for creating UI. For the third line, it is from System Import Window. It is the window framework for the window control. And then the last one is from System.collections.generic import list. This is a window command collection needed for the Revit API. And the best part, most of these lines stay the same for every plugin you create. Just copy and paste them to get started. For the second magic work, it is the get document handle. It is from line 6 to 8. This is the connection between our script and Revit itself. It tells our script, hey, we are working inside Revit and we need access to Revit's function. For the UI docs, it means that it is the UI document. It's used to control selection, view, and user interaction. For the docs DLC work, it is the actual Revit document. It contains all elements, categories, parameters, etc. Think of the docs as the library with all the books, just like the element, and UI docs as the librarian who can show you things and help you select what you need. For the third magic work, it defines the allowed category. It is from line 10 to 20. We list the category that we want to allow user to filter. You can change this list to add or remove category anytime. For other category beside this, check the link in the description below for more detail. This is like creating a whitelist of the category. We only search through these type of elements to keep things fast and relevant. For the magic word fourth, it is the helper function. We can call this the building block. It is from line 23 to line 121. Before we create our window class, we need some helper function that do the heavy lifting. These functions work behind the screen to extract parameter data and find matching element. So for the first helper function, it is convert parameter value to string from line 29 to line 38. So what this does? Revit parameter can store different types of data just like text, number, length, etc. This function converts any parameter value into string. We can compare and display it. It handles string, integer, decimal, and other types. Think of it as a universal translator. No matter what language, data type, the parameter speak, this function translates it to a string that we can work with. For the second helper function, it is load parameter from a category, from line 41 to 62. So what it does, first is take the sample element from a category and goes through each element properties. Then, for each properties, it will validate it in line 47, get the property name from line 48, and organize like a filing cabinet from line 49 to 50. Create a folder for each property to hold all its values. Then, it converts the value to text using our helper function from line 52 and store them. Automatically remove the duplicate one in line 54. Lastly, it will sort everything alphabetically from lines 58 to 60 and return an organized pair like a wall type 1, wall type 2 with a height 3000 or 4000, etc. It's like taking inventory. You go through each item and write down all its properties and their values. The code limit to the first 100 element. You can see from the line 45 the for element in sample element with a colon 100 for performance purpose. If you want more comprehensive parameter data, you can change the :100 to a large number just like :200 or :500 to sample more elements, or even remove the limit entirely by changing for element in sample element :100 to just for element in sample elements to get parameter from all elements in the category. Keep in mind that removing the limits may slow down the loading process if you have large model with many elements. The next helper function is load parameter from all category. It is from line 65 to 91. So what this part does, it goes through all allowed category from line 69, find elements in each in line 70 to 71, and sample the first 50 per category for speed in line 72. For each element, extract all properties in line 74, validate them in line 76, and get properties names in line 77. It's organized like a filing cabinet from 978 to 979. Create a folder for each property names to hold all values found across all categories. It converts value to text using our helper function in line 81 and store it. Automatically remove the duplicate in line 83 and finally sort everything alphabetically in line 87 and 89 and return the final organizer list combining property from all categories. It's like doing a store wide inventory instead of just one department. This function is used when the user clicks the Any Category checkbox because it's needed to search across all categories all at once. The code here is also limited to the first 50 elements per category. You can see from this 972 for performance purpose. If you want more comprehensive parameter, you can change the 50 to a large number or remove the limit entirely by changing to a sample element to collected elements to get parameter from all elements in each category. Keep in mind that removing the limit may slow down the loading process if you have a large model with many elements. And the next helper function is find matching element from line 64 to 121. What this does, it is to decide where to search from line 96 to 110. If all category is checked in line 96, search all allowed category from line 99 to 104. If a specific category is selected from the line 105, search only the category from line 107 to 110. Collect all elements from the search area from the line 98 to 110. Then it will check element from line 114. Look for the selected property in 115, verify it in 116, and convert its value to text in 117, and compare it with the search value in 118. Finally, it will add matching element to the result in 119 and return the complete list in 121 line. That's like a smart searching function. It goes through your entire model and find exactly what you're looking for. Think of all these functions as your hardworking assistant. They do all the heavy lifting, reading the property from elements, organizing the data, and finding the matching elements. The window, the interface you are controlling, is like the manager who tells those assistants what to do when the user click button or select option. Without these assistants, the window would not know how to find everything. For the fifth magic word, it is create window class from line 124 to 137. These create our window blueprints. Think of the class myWindow from the line 124 as a template placed on standard Windows window. You get all the basic features just like show, close, resize, plus your own custom feature. The _init_ function in line 126 is like an opening day checklist that runs automatically when the window is setting everything up. So what happens when the window is open? When the init runs, it does four things in sequence. First, it loads the XAML UI from line 129. It connects your UI designer to Python. Detail will be mentioned below. The second thing is to create empty storage container from line 132 to 133. It prepares a filter1 parameter and filter2 parameter to store property data later, like empty filling cabinets ready to be filled. The third one is load category from line 136. is fill the category drop-downs. Detail we mentioned below. The fourth one is the select event handler. It is line 137. It's connect the button and control to their function. It's like open a restaurant. You set up the table, the XAML, prepare the storage, empty container, write the menu, which is the category, and train the staff, which is the event, all before the first customer arrives. We'll go deeper to talk about the magic work, the first part, the XAML connect to Python, from line 129. The magic is wpf.loadComponents and x:\name. This name does three amazing things. First, load your XAML file. It reads your UI.xaml file, the UI design you created. Second is create all control. It's built all the button, checkbox, and drop-down you designed. And last is collect the XAML to Python. It's link every x:\name in XAML to Python code. How the x:\name works. When you write x:\name equal to check anyone in your XAML file, Python can access it as self-check anyone. It's like giving every UI element a name tag that Python can read and control. After wpf.loadComponent runs in line 129, all XAML elements with x:\name become accessible to Python as table. How it works. In your XAML file, you give every control name using the x:\name equal to something. When wpf.loadComponents runs, it reads all those names. Python can then access each control using the self.something. This creates a bridge between your UI design XAML and your logic in Python. It is important to note that the x:\name in XAML must match exactly with Python code. It is case sensitive. Figurative are like a phone number. One wrong digit and you can't connect. The next magic word we hear is the load category from 139 to 152. What the step-by-step is, first is create an empty list to hold the category name in line 141, like preparing an empty shopping list. Then we'll go through each allowed category one by one in line 142, just like wall, floor, door, window, etc. For each category, it will check if it exists in your Revit document from line 143 to 144. Some category may not be used in your project. If the category exists, count how many elements are in that category in 146 to 147. This check if there's any actual element, not just an empty category. Only add the category that had at least one element to the list in line 148. After checking all category, fill both filter 1 and filter 2 drop down with same list from 151 and 152. Both filters get the same option to choose from. It's like checking which section of the library actually have the book before showing them in the catalog. You don't want to show an empty section that will confuse people. And the next magic word is set up event handler from 154 to 167. This function is called automatically when Windows open. It connects user action just like click selection to response function. Think of it like a phone notification system. When something's happened in the UI, Python get notified and run the right function automatically. What is the step-by-step? You can see there's a plus equal operator here. The plus equal operator means subscribe to this event is tell Python when this happens, call that function. For example, self check anyone dot checked plus equal self on anyone checked in 156 line mean when the checkbox becomes checked, automatically call on anyone checked function. For the filter 1 in 156 to 159, it's connected to any category checkbox. You can check or uncheck it, category dropdown, and parameter dropdown to their response function. For the second filter in 161 to 164, it's same pattern as filter 1 but for filter 2's control. For the button in 166 and 167, it's connect clear and set the button to their function. When you interact with the UI, the connector function runs automatically. You check or uncheck any category, it will trigger on anyone checked or on anyone unchecked in line 156 to 157. When you select a category, it will trigger on cat1 changes when low parameter in line 158. When you select a parameter, it will trigger on parameter 1 changes with low value in line 159. When you click select, it will trigger the on select which find and select the matching element in line 167. You don't need to manually check did the user click something every time. Instead, you just tell Python, hey, when this happened, do that. And Python handles everything automatically. It's like having a smart assistant that watches your UI and reacts instantly to every action. This pattern works the same way for every UI control, button, checkbox, dropdown, text box. Just collect the event to your function and you are done. For the sixth magic word, it is loading parameter when category change. It is from line 221 and 245. So what this does? First, when users select a category, the function runs automatically from line 221 thanks to the event handler from magic word 5. Check if any category is checked in line 223. If yes, it stops early since we don't need category specified parameter. It gets the selected category name in line 226 and validates in line 227. If nothing is selected, it clears the drop-down and stop. Then it converts the category name to Revit's internal format in line 234, like translating Word to code Revit that understand. Then it collects elements from the category from line 236 to 237, assembling the first 100 for speed. Then call load parameters for category in line 239. Our helper from Magic Word 4 extract all you need property and values. Then extract property names in 240 and updates the UI in line 241 to 242. Fill the parameter dropdown and enable it. Finally, it stores all property values in filter 1 parameter in line 243 for later use. Then clear the value dropdown from line 244 to 245. Think of it like a smart assistant that looks through your elements and finds the property that they have. This function uses the helper function we created earlier to do the actual property extraction. The same pattern is repeated for filter 2 in on category 2 changes in line 247 to 271. It does exactly the same thing, but work with the filter 2's control and store data in filter 2 parameter instead. This is the great example of code reuse. Once you understand how filter 1 works, filter 2 works the same way. For every time you write a Revit plugin, you can reuse this pattern. Just change the category and parameter name. For the magic word 7, it's loading value when parameter change from line 273 to 282. What it does step by step is, first, when a user selects a property or the parameter dropdown, this function fires automatically, like from the line 273 thanks to the event handler we set up in Magic Word 5. Get the selected property name from the dropdown from the line 275, like type name, height, comment, etc. Then click if a property was selected and if we have a storage container ready from line 276. This makes sure everything is set up correctly. And next is if everything is good, looks up all values for that property from our storage container from line 277. This is like opening a filing cabinet and finding the folder for the type name, then read all the value inside. After that, we'll fill the value dropdown with those values in the line 278. Now, the user can see all possible values like warp type 1, warp type 2, and warp type 3. Next, it is enable the value dropdown so the user can select or type a value in line 279. Finally, if something went wrong, which means no property selected or the storage is not ready, it will clear and disable the value dropdown in line 281 to line 282. This will keep the UI clean and prevent error. It's like opening a drawer full of options. Once you pick the property, all its possible values appear. The values were already collected and stored when the user selects the category, so they're ready instantly. The same pattern is repeated for filter 2 in on parameter 2 changes in line 284 to 293. It does exactly the same, but works with filter 2 control. This is a great example of reuse, as I've mentioned. Once you have understood how filter 1 works, filter 2 works the same way. For the last magic word, the magic word 8, it is select element in Revit from 311 to 372. What this part does, here is the step-by-step explanation. Part 1 is the line 311 to 328 is getting filters 1 information. When the user clicks selected, this function runs automatically. Validates the filter 1 has a property selected in line 314, then stop early if no in line 315. Next, it will get the property name in 317 and value in 318. The value can be from drop-down or typed by user. Then, it will validate a value existence in line 320. It will stop early if not in line 321. Then it will determine the category set to none for any category from line 324 or get selected category if checkbox is unchecked from 325 to 328. The part 2 is finding matching element for filter 1 from line 3v1 to 3v2. It will call the get elements for filters in 3v1. Our helper from Magic Word 4 find all matching elements. Then it will collect the element ID in 3v2, unique number of the Revit to be used to identify each element. For the part 3, it will check the filter 2 in line 339 to 352. It will check if filter 2 have a property selected in 339. If not, skip filter 2. Then, the filter 2 works exactly same as filter 1 from 340 to 352. It will get the property name and value, determine the category, find matching element, and collect their ID. For the last part, the part 4 is combining the filter from line 355 to line 364. It will check if the filter 2 is active. If not, use only filter 1 result in 364. If filter 2 is active, check the OR checkbox in line 356 to determine how to combine. If it is in OR mode, which is union in line 359, it will combine both lists, element matching filter 1 or filter 2. If an element appears in both lists, it only shows once, so there will be no duplicate. In AND mode, which is the intersection, from line 362, it will find only the element in both lists, element matching the filter 1 and filter 2. Only elements that satisfy both conditions are selected. For the last part, it is selecting element in Revit from line 367 to 372. If elements found in 367, we convert the ID to Revit format in line 368, select them in 369, and then show count in 370. If nothing found, show no element find message in line 372. This is where everything comes together. The user clicks select, and we use all our helper function to find and select the matching element. So for the last magic work, show the window. It is from the line 375 to 376. This is the final magic work. It displays your beautiful UI window. Here are some common patterns you will use again and again. For the pattern 1, it is enable or disable a control. For the pattern 2, it is clear previous selection. For the pattern 3, it is get editable combo box value. For the last pattern, the pattern 4, is convert to collection, because you need to explicitly indicate what kind of list you're creating for the Revit API. For the pro tips here I would like to share is, first, always test your UI in PyRevit after creating XAML. For the second one, make sure the Xcolon name match exactly because it is case sensitive. For the third one, use print statement to debug what's happening. Lastly, start with simple UI, then add complexity later. Today, you build a real-world selection tool, complete with UI logic and Revit API calling. You can now filter and select any element in seconds instead of minutes. With this tool, you can avoid repetitive selection tasks and starting automating your Revit workflow. No more clicking through hundreds of elements one by one. But I also know many of you are busy fighting deadlines, meeting client pleasure, or debugging error just trying to set up PyRevit or installing Visual Studio. That's exactly why I created Preview the add-in, a professional version of everything that we built here. You can use it right away, with no manual setup, no coding error, and no admin rights. And experience these automation felt like when they run at full speed. It's not just a shortcut, it's a motivator. Once you taste what the supported version can do, you will be inspired to learn how it works under the hood. For this time, I have built it as a dockable panel with first, a modern UI matching Revit ribbons, and fast performance with instant filtering, a safe filter set that you can reuse, and automatically roll back safety. This growing toolkit now includes all tools from lesson 1 to now, and more will coming. For the price of a copy a month, you help me keeping a free, high-quality tutorial for everyone, while getting the polished, professional version for your daily work. You can join via Patreon, Ko-Fi, or buy me a copy. Links are in the description below. Even bits of support keeps this channel alive, so together we can make Revit automation easier, faster, and more accessible to everyone. Before you go, what plugin do you think would make your life in Revit easier? Drop your idea in the comment. Your idea may become the next lesson. Let's build smarter, not harder. I'm Clement. See you in the next video.